All right, so we're going to talk about approximating. Sometimes it's called linearization. Approximation is used to approximate the slope of the tangent line at a given point that's near a point where the slope of the tangent line is known. So if I know the slope of the tangent line at, I don't know, 7, and I want the slope of the tangent line at 7.2. So I'm off just a little bit. I'm off by 2/10, okay? Here is your formula. So this would, if I know f of 7 is whatever, and I'm looking for f of 7.2, okay? So I'm looking for f of 7.2. So it is approximately f of 7, a is the known value, plus f prime of 7 times the difference between what I want and what I know. So let's memorize this real quick. F of 7, so f of what I know, plus the derivative of f of 7 times the difference between what I want and what I know. What you want goes first. I want the 7.2. So sometimes this value will be positive and sometimes it will be negative, because I could want f of 6.8. So then I would have 6.8 minus 7. So that distance or that difference right there would be negative. This formula states that the value of a function at x, which is near a, equals the value of the function at a plus the product of the derivative of the function at a and the difference between x and a. If the function is concave up, the approximation is going to be a little less. And if the function is concave down, the approximation is going to be a tad too much. So let's look at number 1. The function f is twice differentiable, where f of 3 is negative 2 and f prime of 3 is 5. Write the equation of the tangent line and use it to find the value of f of 3.1. So I know this is an approximation. It doesn't say approximate anywhere in there, but it's giving me information about f of 3, and it's asking me for information about f of 3.1. So I'm going to start approximately f of a plus f prime of a times x minus a. Okay, so there's my formula. Now let's make sure everybody knows what's what. So a is 3. X is the 3.1. And I don't want you to get all worried about A's and X's. I want you to know that the known value goes in here. What you want goes right there. So I'm trying to find the value of f of 3.1. I'm trying to approximate what that is. So f of 3.1 is approximately, sorry, I can do better than that. F of 3 plus f prime of 3 times 3.1 minus 3. Well, f of 3 is negative 2. F prime of 3 is 5. And 3.1 minus 3 is a 0.1. So negative 2 plus 0.5. So negative 1.5. F of 3.1 is approximately a negative 1.5. And that's without ever knowing what f of x is. So now let's look at this one. I want to approximate the square root of 9.01. Well, if I had a calculator, I'd just type that sucker in. So obviously this is going to be on the non-calculator part of the test. So I know that my function is the square root of x. I'm also going to need his derivative. Be x to the 1/2, so 1/2 x to the negative 1/2. I know what the square root of 9 is. So that's x. No, that's a, sorry. X is the 9.01. So I want f of 9.01. So that's going to be f of 9 plus the derivative at 9 times the difference of what I want minus what I know. Okay, well, f of 9 would be a 3. F prime of 9, square root of 9 is 3, move it to the bottom, 1/3 times 1/2 is 1/6. Now again, this is most likely no calculator right here. So when I do this, 9.01 minus 9 would be 0.01, not 1/10, 1/100th. So 3 plus 1 over 600, which as a decimal is, no. So we'll just say it's 3 1/600. How's that? If you go decimal with this, like if you were to go decimal, then that would be 3.0016 repeating. And then if you straight up type this in, you get 3.00166204. So if it was multiple choice and it happened to be calculator active, obviously they would have both answers on there. They're not asking you to just square root 9.01. All the answers would be ridiculously close to 3. You know that it's going to be just over 3 because 9.01 is bigger than a 9. So just take your time, use the formula. Now, the square root of 9.5 is going to be a little bit bigger. So tell you what, hit pause and try number 3. All right, so f of 9.5 is approximately f of 9 plus f prime of 9 times 9.5 minus 9. So that's the same, and that's the same, and that's a 0.5, which is a half. So that's 3 plus 1/12, which is 3 1/12, which as a decimal, that's not 12th. Yeah, it is. Yeah. Is 3.08333. And I didn't type that into my calculator. I don't know what it is, but I bet it's close. The farther you get away from the known value, the less accurate your approximations are. So the 9.01 is going to be more accurate than the 9.5. Okay, number 4, approximate 3.98 to the 4th. Okay, so my function is going to be x to the 4th. Its derivative is 4x cubed. What I know is a 4. Like I can do 4 to the 4th. but what I'm wanting is a 3.98, which is just shy of that. So if I do f of 3.98, I'm getting f of 4 plus f prime of 4 times what I want, 3.98, minus what I know. So that value is going to be negative, which makes sense because it's going to be under. So f of 4, 4 to the 4th is 256. 4 cubed is 64. So 256. F prime of 4 is also going to be 256 because this is going to be 4 cubed times 4, which basically means I have 4 fours. So 256 times a negative 0.02. And I just crammed that in my calculator and I got 250.88. If you type it in, you get 250.9182722. So we are not even accurate to 1 decimal place. So again, it is a gross approximation. Okay, number 5. Find a linear approximation to y equals 2 to the x at x equals 3. Use that tangent line to estimate x equals 2.97. So I want to estimate, which means approximate. So let's see. My f of x equals 2 to the x. My f prime, okay, leave it, derivative of the up, ln of the base. So 2 to the x ln of 2. My a value is, let's see, 2.97, so I'm going to go with 3. And my x is 2.97, because that's what I want. Oh, and it tells me that I'm going to use x equals 3 as my known value. So let's see, I'm approximating f of 2.97. So f of 3 plus f prime of 3 times what I want minus what I know. All right, f of 3. So that would go into here. And 2 cubed is 8. F prime of 3 is going to be 8 ln of 2. And this is going to be a negative 0.03. Multiple choice might leave it there, or they might go decimal. If you type this straight in, I get 7.8336, and you can do 2 to the 2.97, and you should be in the ballpark. Find the linear approximation, cube root of x equals 8. That makes sense. I know what the cube root of 8 is. Then use that linear approximation to approximate the value of the cube root of 10, which I don't know, and the cube root of 16, also don't know. So let's establish some stuff. F of x is x to the 1/3. F prime of x equals 1/3 x to the negative 2/3. I know, which means that's my x value. Hold on, I always get those mixed up, and I don't want to tell you wrong. That's my a value. My a value is 8. Then I'm going to have two x values. I'm going to have x equals 10 and x equals 16. So to find f of 10, that's going to be f of 8 plus f prime of 8 times 10 minus 8. And if I'm going to set the other one up, f of 16 is going to be f of 8 plus f prime of 8, 16 minus 8. Okay, so f of 8. If I plug an 8 in there, I'm going to cube root it, I'm going to get a 2. F prime of 8. All right, 8 to the negative 2/3. That means cube root me, square me, move me to the bottom. Cube root me, I'm a 2. Square me, I'm a 4. Move me to the bottom, I'm a 1/4. Times the 1/3, that's a 1/12. And then this, there you go. So this is 2 plus a 6, so 2 and a 6, which is 2.16 repeating. And this is 2 plus, let's see, 8 over 12 is 2/3, which is 2 and 2/3, or 2.6 repeating. Okay, now let's try some trig. Use differentials to approximate, there's your keyword, sine of 46 degrees. I don't know sine of 46 degrees, but I do know sine of 45 degrees. Here's the thing. This formula does not work with degrees. I don't know why. I'm sure there is some reason, but I don't know what it is. But I know that you can't use degrees. So I have to turn this into radians. So what 46 degrees is it's 45 degrees plus 1 degree. And I know what 45 degrees is. 45 degrees is pi over 4. You also know what 1 degree is. 1 degree is pi over 180. And if you don't know that, that's why. Remember, to change degrees into radians, you multiply by pi over 180, and to turn radians into degrees, you multiply by 180 over pi. The reason we're using that ratio is because that is the cleanest ratio on the unit circle. That's pi, that's 180 degrees. It's the same thing. It's like 12 inches, 1 foot. It's the same thing. So there shouldn't be a degree symbol here. Sorry. All right, so here I go. My function is sine of x. My derivative is cosine of x. So f of 46 degrees, which I'm going to go, well, I'll leave it in degrees there, but on the right-hand side, I'm going to convert it all. So this would be f of, not 45, because it won't do degrees, f of pi over 4 plus f prime of pi over 4, which I all know. It would be the same if I used radians degrees. Here's the difference right here. If you stayed in degrees, then this would be 46 minus 45. It would be 1 degree. But I have to do this in radians. So what I know, and I'm not even going to add these two together. I'm not even going to get a common denominator, because watch what's getting ready to happen. What I'll have is 46 degrees, which is pi over 4 plus pi over 180. That's the 46 degrees, minus the 45 degrees, which is pi over 4. So you guys can see the pi over 4 is going to cancel, and I'm going to have pi over 180, which makes sense because 46 minus 45 is 1 degree, and 1 degree is pi over 180. Okay, so now I need to do sine of pi over 4. That's root 2 over 2. And, well, this is nice. Cosine of pi over 4 is root 2 over 2 times pi over 180. Type all that wonderful mess in 4 decimal places. And then you can take your calculator, make sure you're back in degrees, and type in sine of 46 degrees and see if you're in the ballpark with 0.7194. Okay, approximate sine of x at x equals 1.05. Now this one's tricky, I think, because it's hard to see like x equals 1.05 and x is my angle sine of x. But that's not 1.05 degrees, which means it must be radians. But it's not 1.05 pi, it's 1.05, like pure radians. So you have to start playing around with your unit circle and figuring out which angle you know matches up with a 1.05 or gets you in the ballpark. Okay, so again, I know that x is my angle. I know 1.5 is not in degrees because I don't see a degree symbol. So I know it's in radians. But I can't just put a pi on it because pi is multiplying it by 3.14. I can't do that. So what I'm going to do is I'm going to take an educated guess to get me started. And I'm going to start looking at those guys until I can kind of hone in on a decimal value that's 1.05. Now let's be smart about it. I know all these pi's in the numerator are 3.14. So I need a 3.14 divided by something that's going to give me a little over 1. I'm starting with that guy because 3.14 divided by 3 should go 1 and a little bit. And if you type in pi over 3, you get 1.047. So my known value is going to be pi over 3. So I can still use that stuff because I have the same parent function. So what I'm trying to find is f of 1.05. I'm going to use f of pi over 3 plus the derivative of pi over 3 times the difference between a pi over 3 and a 1.05. So what I want minus what I know. Okay, let's see. Pi over 3. Pi over 3 is this one, and that is pretty ugly. So sine of pi over 3 is a root 3 over 2. The derivative would be cosine of pi over 3 is a 1/2. And 1.05 times pi over 3, I'm just going to leave that be and type it all in one swoop. So pause it, type the whole bad boy in at one time. And I got 0.8674. Again, 4 decimal places. Okay, number 9. All right, so this is one where I don't have a function. The function is twice differentiable. It gives me f of 2, f prime of 2, and f double prime of 2. That's interesting. What is the value of the approximation of f of 1.9 using the tangent line to the graph of f at x equals 2? So I don't even have what f is. I don't even know the function. But I'm trying to find f of 1.9. I'm going to base it off of f of 2. F of 2 is 1, f prime of 2 is 4, 1.9 minus 2 is a negative 0.1. 0.6. No calculator. You got to be able to do little decimal multiplication and subtraction of some decimals in your head. Make sure you can see the decimal. Okay, last one. Tell you what, pause it, try it yourself, then hit play and check it. Okay, f of x is 2 cosine x plus 1. F prime of x is negative 2 sine x. And that goes to 0. So I want f of 1.5, and that was nice. They told me that I'm supposed to use pi over 2 as the approximation. So I'm going to do f of pi over 2 plus f prime of pi over 2 times what I want minus what I know. Pi over 2. 0, 1. Okay, cosine is the x value. So 0 times 2 is 0, plus 1 is 1. Okay, f prime of pi over 2. Okay, so sine negative 1, or 1 times negative 2, so negative 2. And then whatever that mess is. Okay, this one, let's try to clean it up from here without a calculator. Like, let's say it's multiple choice and the answers are not streamlined into a calculator. All right, so let's clean. So 2 times 1.5. So 2 times 1 would be 2, and 2 times a half would be a whole. So that would be 3. And then plus 2 times pi over 2 would be a pi. So negative 2 plus pi. There you have it. It's not difficult at all. You've got to understand the wording so you know when it's asking you to do this. And know the formula, which I hope you kind of already do. Look for things like linear approximation, use the tangent line to approximate, estimate, those kinds of words. That's how you know that you're headed towards that formula.